Hi, today I'll be going over motion and kinematics in one dimension. So let's get started. So let's first start out with position and displacement. So position is basically where an object is, and that's denoted with the term or variable x. So in most problems, in most cases, you see position as x sub t. And the thing is, with position, you can go in either a positive direction, that is this way, or a negative direction from an origin point. So displacement is basically the change between position 1 and position 2. And this is denoted with the term delta x, with the Greek letter delta meaning change in. And the formula for finding the displacement of an object is delta x is x position x2 minus position x1. And with this, positive and negative signs play a factor. And positive signs mean that the displacement is in the positive direction, while a negative sign means that the displacement is in the negative direction. If we ignore signs, we basically get magnitude, or the absolute value of the displacement. For example, the magnitude of -4 meters from the origin point is just 4 meters. So magnitude basically is how far an object went, and it does not denote for direction, while displacement denotes direction. So let's move on to velocity. So average velocity is basically the change in displacement, or x, over the change in time. And basically what you have is you have the average velocity as being delta x over delta t, or the change in position over the change in time. And basically how this works is you have v average, or you can denote it by using v bar, is x2 minus x1 over t2 minus t1. And in a graph, this would basically be the slope formula graph. So let's say in a linear graph, x is the y-axis and t is the x-axis. So it's basically just the slope of the line. That's velocity of position. And you can use the slope formula to calculate it as shown below. So average speed is basically total distance over total time. So the thing is, velocity denotes for position and what direction it's in, while speed basically just is total distance. And there's a difference between distance and displacement, because distance is just how far you went, while displacement is basically how far you went to a certain direction, then how far you went to the other direction. So they're both different. So displacement, again, takes the positive and negative distance into account, while average speed is just the total distance covered. And the way to find average speed is basically finding the total distance, in which you just get the absolute value of the different positions and add them up over the total time, which is just the final time minus the initial time. So that's how you find average speed. So instantaneous velocity and speed. So the thing with instantaneous velocity and speed is that instead of having the velocity and speed from over a long point, such as, let's create a graph like this. Let's say instead of finding the average velocity and speed from, I'll change the graph color, from, let's say t equals t3, my bad, to t equals 1. So let's say instead of finding the average between velocity from time 1 to time 3, you can find the instantaneous velocity, or the velocity at a certain point. And for that, you just, again, take the slope at that certain point. But the problem is that the numbers get extremely small. And so what you have to do is you have to learn this concept called the derivative, which is something you learn in calculus. And I won't be going over the derivative in this lesson, as it's a whole long topic. But basically the instantaneous velocity is when you find like the velocity at a very small amount of time. So you can basically solve these problems by finding the derivative of a position equation or by finding the area under the curve of an acceleration graph. And that I'll be going over more later on. And I'll bring in integration into this also. And instantaneous speed is basically just the absolute value of dx dt, or instantaneous velocity, because again, speed does not take the position if it's positive or negative into account. So now let's go into acceleration and just put everything together. So with acceleration is basically how fast the rate of velocity of an object is. And frankly, it's a little bit confusing, but it basically denotes how fast something is accelerating. So for example, let's say, I don't know, like a Tesla that can accelerate from 0 to 60 kilometers, 0 to 60 miles per hour, my bad, in around 3 seconds. So acceleration is basically finding how fast it goes from 0 to 60. So acceleration would just be 60 minus 0 over 3. And acceleration is just 20. Just basically 20 miles per second, I guess, second squared. So yeah, I'm not sure if I got the units right, but I guess you get the gist of it. So acceleration is basically, again, how fast the rate of velocity of an object is. And acceleration can be found by getting the derivative of velocity over the derivative of time, or getting the second derivative of position over time. And so, again, a is the second derivative of position. And you can find the average acceleration by finding the final velocity minus the initial velocity over time. Or you can get it the instantaneous acceleration by just finding the derivative at that certain point. So let's actually put everything together. So you have A and you have X. Well, you have V and then you have X. So acceleration is the first derivative of velocity. So A is v prime of t. And v prime of t is the, well, v of t is the derivative of position. So A would be the second derivative of position. And so basically you just find the second derivative of a graph or an equation, and you just find the second derivative to find the acceleration, or the first derivative to find the velocity. But what if you have to find the velocity from acceleration? So basically what you can do is, let's make this into a graph. So let's say in this, let's just make this into a graph. So at a certain point, and I'll change my color so to white. So let's do t equals 2 to t equals 4. And this is A over t. So basically what velocity is when when you have an acceleration graph is that you're basically trying to find the area under the curve. And sorry for my bad writing, doing it with the, I think it's kind of hard. So basically what you're trying to find again is the area under the curve, and this is basically integration. So v of t, velocity, is basically the integral of acceleration, as basically velocity is the speed and acceleration is how fast it's going. And then same with position. So position would also be, 1 second. Oh. So position would also be, so, and position would be x of t. equals the integral of velocity, v of t dt. So you're basically trying to find the area under the curve if you want to go up. So let's make it into a ladder, I guess. So you have x is at the top, b is in the middle, and a is at the bottom. If you want to go down, drive, up, integrate. So that's how I would recommend thinking of it. So now I guess we put everything together, and now let's move on to graphs. So again, so graphs are basically like this. So with graphs, again, what you have to do is if you want to find the derivative of a position graph, which would be velocity, you have to find the slope. So you have to find the slope of this point to find the derivative at the derivative. And so you basically do that. But then let's say for this one, velocity versus time. If you want to find the position, you have to find the area under the curve for that point. So let's say from 0 to 10, 14. So if you want to find the area under, well, the position for 14 seconds, you just have to find the area under the curve. And for most basic physics problems, what they will do is they'll just have you use a equals base times height, or 1/2 base times height, and just find the area by just doing the math instead of having to do complex integrals. So you don't have to know the full calculus just yet, but it is recommended learning so, or at least the theory aspects. So I guess that's it with graphs. So kinematics. So now that we basically finished the basics of motion, let's move on to kinematics. So kinematics is basically a set of equations that were derived in order to help find the velocity, acceleration, or time, or position when you have a constant acceleration. And a constant acceleration is basically it's accelerating at the same rate instead of changing its magnitude. So, sorry about that. So the thing is that you have 5 of these equations. So what you have with these are these 5, and they all have 1 or 2 missing quantities. For example, this one, 2.11, it's used to find velocity or acceleration, and the missing quantity is position. For this one, you don't have a final velocity, and you only have the initial velocity, acceleration, and position. This one, you don't have anything for time, so you can solve it for problems without time. And this one, you have it for problems without acceleration, so and so on and so forth. And basically, what these problems do is that they basically allow you to basically cherry pick an equation which you want, so you can basically solve problems. So free fall acceleration. So the thing is, Earth has gravity, which has a constant of 9.8 meters per second squared. And this can be called G, but I like to call it A just for cohesion, and you can do whatever you want. So let's just say you're angry and you throw an apple into the air. I don't know why you would do that, but let's just put it in this context. So the thing is, the apple, even if you throw it, it would have a constant acceleration of negative 9.8 meters per second squared, while the velocity would continue to change. And the thing is, basically, these are just kinematics problems, but you have the acceleration equaling 9.8 meters per second squared. So how to solve kinematics problems? So the first thing you have to do is write down your variables and all the information that you need to know. Second, you have to find an equation that works to find the missing variable that you want. And lastly, solve. So let's try some practice problems. So this one. So again, let's follow what I said to do. To basically first list all the variables and write everything down. So let's switch to red. So a car starts from rest. And when something starts from rest, you know the initial velocity would be 0. and it accelerates uniformly. So there's just a over a time of 5.21 seconds. So t equals 5.21. For a distance of 110 meters. So x would equal 110. Find the acceleration. So basically what it's asking for is to find the acceleration. And I think I know just the equation that we can use for this. So let's use x minus x initial equals v initial, v sub time, plus 1/2 acceleration times time squared. So x minus x initial, we can sub in 110 for that. And basically, we know v initial is 0. So 0 times 5.21 would still be 0. So you can just cross that out. And then you have plus 1/2 a to the t squared. And we're trying to find a. So we're trying to find a here. So basically, what you do is you just make it 1/2 a times 5.21 squared. Now you just solve for a, and you multiply both sides by 2. So 220. And then you also divide both sides by 5.21 squared. So, okay. So now 220 divided by 5.21 squared equals 8.10 meters per second squared. And this didn't account for sig figs. So that's the acceleration of the car, 8.1 meters per second squared. So why not you try the second problem on your own? I would recommend getting all the kinematic equations and just seeing which one would apply. So why not try it on your own now? Okay, so now that you're probably done, so let's try the second problem. So a race car accelerates uniformly, so it only has one a value, from 18.5 meters per second to 46.1 meters per second in 2.47 seconds. Determine the acceleration of the car and the distance traveled. So v initial would be 18.5. V final would be 46.1. Time would be 2.47 seconds. And what you're trying to find is acceleration and distance. So the thing is, we know that acceleration is delta v over delta t. And we know that time is 2.47 seconds. So we can basically find acceleration by finding the final velocity minus initial velocity, because v final minus v initial equals delta v. And I guess you probably would remember this when I talked about position. And when you have delta, that's basically what it's asking, change in. So v final would be 46 minus 0.1, sorry, 46.1 minus 18.5 over delta t, which is 2.47. And we find acceleration, and that equals 11.2 meters per second squared. So now that we know acceleration, I'll erase that out, and then let's solve for x, or position. So now that we know that, let's do position. So let's try to find an equation that may be able to solve for this. So why not let's use delta x which is the distance traveled, final distance minus initial distance. And so delta x equals VIT plus 1/2 AT squared. I apologize for the bad handwriting. So V initial T is basically 18.5 times 2.47 plus 1/2 11.2 V7 acceleration multiplied by 2.47 squared. And so basically you just plug it into a calculator, and what that gives you is delta x of 79.8 meters. And so that's our delta x, and this is our acceleration. So distance traveled is 79.8 meters, and acceleration is 11.2 meters per second. So let's clear all drawings. And now we just have free fall acceleration problems. And I just got one of these, and I thought this would be a fun one to do. So if you are in the same physics class I am, you would probably recognize this problem, but I felt it would be a good one to go over. So a hot air balloon is ascending at the rate of 12 meters per second. So we can determine that V initial is 12 meters per second. And is 80 meters above the ground. So X initial, 80 meters, X final, 0. And it's basically saying that when a package is dropped over the side, what speed does the package hit the ground? So it's asking us to find V final. And it's also asking us, we need acceleration. So acceleration would just be negative 9.8 meters per second squared. So let's find the kinematic equation that may work for this. So why not let's use V velocity squared equals initial velocity squared plus 2 times acceleration and x minus x0 or x initial. So basically what you have is you have to just solve for velocity. So you have V squared and you plug in V initial squared, so 12 squared plus 2 times negative 9.8 times x minus x initial, which is negative 80. And so then you just get multiplied by 1/2 or exponent of 1/2 and then make it to the 1/2. So V will equal square root 144 plus 2 times negative 9.8 times negative 80. And basically what you have to do now is just plug it into a calculator. So V final would finally be 41.37 meters per second. And basically that's how you do these sort of problems. Just write down all the variables and just find the kinematic equation that would work. So I guess that's pretty much it. I hope you found this video useful, and thank you very much and stay safe.